Okay, so we have this. We have these shortcuts. This little foldable book that you have. You're gonna look at all the definitions that are already printed for you, and you're gonna fold these tabs into the middle. All right, that's gonna create your foldable. If you don't want to fold it yet, you don't have to. So these are the only 5 shortcuts that exist. The other way, read. The other way. Flip it over and fold it. These are the only 5 shortcuts that exist in geometry to help prove congruence. And let me know if I'm losing you, okay? Okay. So I said this to third period. Imagine that if you go on Match.com, the only way to find a perfect partner is if they check all 6 boxes. Like in our triangles, you have to check all 6 boxes. It has to have 3 congruent sides and 3 congruent angles for the 2 shapes to be congruent. Yesterday was a lot of work. You had to do all 6 parts. So Match.com says you need all 6. Well, here comes eHarmony. And they're like, hey, bro, if you can just get 3 of them, you can assume the other 3 are also true. Does that make sense? Mm-hmm. So if you're looking for a partner who is tall, dark, handsome, fast car, big bankroll, dresses nice, that's what you want. If that guy checks all 6 of those boxes, he's a match. But here comes Tinder. And Tinder says if he's tall, dark, and handsome, you can assume he has a fast car, you can assume he has a big bankroll, and you can assume that he dresses correctly. So any of those 3 will provide the other parts of the information. So instead of doing our checklist with 3 sides and 3 angles, we can cheat and use shortcuts. That makes your proofs a lot shorter.
That's what we were learning yesterday.
We learned that yesterday. So we learned this one yesterday, the side shortcut. So we're going to mark it so you know what it looks like. If you are given this side and this side are congruent, if you are given these 2 sides are congruent, and if you are given these 2 sides are congruent, you can skip all the angle statements and assume 2 triangles are congruent. So do you know anything about angle A and angle D right now? Does it tell you right now, does it tell you anything about their sizes? No. But because I have 3 pairs of congruent sides, it is implied that these 2 angles are exactly the same size. It is implied that these 2 angles are exactly the same size and that these 2 angles are exactly the same size. It's a shortcut. It takes your proof from 6 steps down to 3. Does that make sense? Okay. So the other one that we talked about yesterday was the side angle side shortcut. If you can minimally prove, or if you are given these 2 sides are the same length, and these 2 sides are the same length, and the angle included between those sides is the same, you can immediately assume all the other parts of the triangles are the same. Does that make sense? Yeah. So right now I know that AB and DE are the same size, and AC and DF are the same size. And I know angle A and angle D are the same size. Once I have that information, I can assume and I know that this side is the same as this side, even though it's not marked. Those are the 2 we learned yesterday. The 2 new ones, the angle side angle shortcut. So that's 2 pairs of congruent angles. There's 1 pair of congruent angles. Here's the second pair of congruent angles. And now the side must be included between those 2 angles. If I am given that information, I can prove that all the other parts that are unlisted are also congruent. It's a shortcut. That should be like a 3-step proof. If you can prove those 3 things, you're good. And then this is the one that people don't like. The angle side shortcut. Okay? For angle side, you need 2 pairs of congruent angles and a side not between the angles. So it could be AB and DE, or it could be BC and EF. So we're going to do the right side. So now you have two A's, and the S is not between them. If you have that information, you can assume all the other parts are the same. And this is the one that everybody misses on their test. HL.
Hypotenuse.
What happened? Did you just read it?
Hypotenuse.
Yeah.
Says it on the front.
So with right triangles, we don't call things angles and sides. With the right triangle, if the hypotenuses are the same and the legs are the same, that immediately justifies congruence.
Well, can't you include the
How do you know?
those two sides of the same?
Well, that's basically the same thing as side angle.
Okay.
Oh, just kidding.
Or angle side.
And so if you look, if we abandon the HL part and we call them this angle is congruent to this angle, and this side is congruent to this side, and this side is congruent to this side, I have two sides that are congruent. But now the angle is not between the sides.
But isn't that?
But doesn't that not prove?
Right? And ASS doesn't prove SHIT.
Yeah.
So that's why we don't call it the ASS shortcut, because that's bad.
How
No,
come
no.
we do
But we
two
call it the
angles on the
hypotenuse.
side?
Hmm?
So does it only work with right angles?
It only works because they're right angles.
Same thing.
How do
Well,
we
like how?
do two angles on the side, but we can't do two sides on an angle?
You want to see the? It's a hard picture to draw.
Because it's
Okay.
just goes.
So this angle. Hold on. This. I can do it. I can do it. I can do
Oh,
it.
that does make sense actually.
This angle. I just did this earlier. Put me on the spot.
No.
What is the video
Okay.
doing?
Yeah, and I'm videoing it. So this side and this side, that's ASS. But if I take this line right here and I reflect it over the altitude, see how I didn't? These two lines are exactly the same length. But this small triangle and this big triangle are two different sizes. That's why ASS doesn't work. Okay,
I don't
so.
know how you just added a line in there, but.
Okay.
No.
So if I drew, so this is 7 long, this is 6 long, and this is 60 degrees. This is still 6 long, this is still 7 long, and this is still 60 degrees. But are those the exact same triangle?
No.
No, that's why ASS doesn't prove SHIT.
Oh.
That's the one that doesn't work. Now, if I do HL, there's no way to force a different triangle if those two constraints are in there.
Because the what's it called?
Pythagorean
Right
theorem.
angle.
BC only like hits the 90 degrees at one point.
Right. It's Pythagorean theorem. If a squared plus b squared, if a squared and b squared are the same number, then c squared has to be the same number. Because you're like putting it into an equation. All right. So this is your toy. So the two that don't work, this does not work. Or if you write it this way, ass and ass backwards don't prove congruence. It doesn't work. Or angle, angle, angle does not prove congruence. Any other shortcut will prove congruence. So I want to play with your toy here for a second. Are you ready to play with your new toys? I know, nobody is. So on a quiz, you would see something that looks like this. And it's going to ask you, hey bro, are these two triangles congruent? So what you have to do is list out what you have. This is nowhere in your notes. This is just up here because I want you to play along with me. And this is going to be the first step to our proof. What shortcut do you see? I see this side is congruent to this side. I see this side is congruent to this side. And I see that this angle is congruent to this angle. That is the ASS shortcut. Does that shortcut prove congruence?
No.
So these two triangles are not congruent. Right? Or I could do something like this. Are these two triangles congruent?
No.
No, that's just.
Yes.
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 I have this S is congruent to this S. I have this A is congruent to this A.
And then
And
reflexive.
line
property.
And then a lot of times in your proof, you will see this line, and it is your job to know that it is the same as itself. So you have two S's. Where's the A? Is it between the S's or is it outside the S's? So yes, these two triangles are congruent by the side angle sine shortcut. So even though that's the only thing that I know, now that I know that the side angle sine shortcut works, I can go back and I can add this. This is also true. This is also true. This is also true. By using that shortcut, right? It's not necessarily right. Okay? So the question on the quiz is, what shortcut proves that these two triangles are congruent? That's the SSS shortcut.
Because it reflects it.
Because of the reflexive S in the middle. Does that kind of make sense?
Yeah.
Generally, you guys do okay with this.
Side angle.
No.
No.
Yeah,
It's
side angle.
nothing. It's
Oh,
it's
it's
ASS.
See how you could make side angle side out of that if you put the letters in the wrong order?
Yes.
But this A is not between
Yeah.
the S's. So the A would have to be right here for it to work. Otherwise, right now it doesn't work. Okay? So I would like to get to the point where we're going to start practicing for your test. So in one of those papers I gave you, you should see this proof. And we're going to do this proof together. We're not going to do all of these. We have so many papers because I didn't want you to write a whole lot besides what was worth writing. It's printed for you. So when you plan for your proof, the first thing you have to do is look at those two triangles and figure out what shortcut will work.
SSS.
Okay? They gave us this S is congruent to this S. They gave us this S is congruent to this S. In every proof you do, there will be something that you have to see and recognize. And Presley said there's another S hiding in there somewhere.
It reflects it.
Reflexive.
So I know that this S is congruent to itself. There's the whole proof. Now we just have to write it down. So step one, I want to use the SSS shortcut. That's my goal. Line KL is congruent to line NL. Why is that true?
Given. Can we just put both of them on the same one?
If you want, but the reason I separate them is for this reason right here. This statement says that a pair of sides is congruent. Number two, line KM is congruent to line NM. Why is that true?
Yeah.
This statement describes a pair of congruent sides. So right now in my proof, I have two of my S's done.
And
Line
then
LM is congruent.
reflexive. LM.
Line LM is congruent to line LM. It's congruent to itself. You will use this a lot on your test. Why are those two pieces congruent?
Reflexive property of congruence.
The reflexive property, that is another side statement. I have all three of my S's. Does SSS prove congruence?
Yes.
So if it proves congruence, my last step is writing triangle KLM is congruent to triangle NLM. I'm just copying this part right here. And then writing the shortcut that I used, and you're done.
That was easy.
It's not that bad. The hardest part of these proofs is determining which shortcut to use. What do you think? First one.
Good.
Mediocre?
Yeah.
Do you feel like you're catching up a little bit?
Yeah.
The next
What if?
one.
Wait. So if the lines like weren't connected, I mean the triangles weren't connected.
then it would be very difficult to do. Usually with our proofs, we will either overlap or connect the triangles so you have some way to justify that, right? But you're talking about like, what if it was like this,
Yeah.
and they give you, people a lot of times want to add that, but it's not, you can't just create it. It has to be either drawn for you or visibly evident for you to use it.
So that's like not.
This is a no. These two triangles are not congruent.
Because you don't have enough information.
I don't have enough information. Okay, put your pencil down. You're welcome. We're just going to talk about this one. The first thing that you need to do is plan what shortcut you want to use to prove that those two triangles are congruent.
Which one?
Side.
Exactly.
Side.
Which ones? There's 5 triangles up there.
VWX. Oh, that's
Oh,
a big one.
right? So when you start actually looking at it,
I just-
VWX,
No,
oops,
that's not there. Well, that is one of the ones.
VWX, oh my gosh, and WVZ.
Okay, well, they're
And
the
then
same
another
base.
one.
Okay, now that you actually see which two triangles you're trying to do, let's just plan out what the proof would look like. This is a
Wait.
10-step proof. We're not going to do 10 steps
We
today.
can do 1 + 2 is equal.
No, that's confusing now because there's a line of 2 and there's one.
Okay, well, the
Okay,
two.
okay, so you see
lines-
how this side is congruent to this side? I don't know why we're
Yes.
writing in yellow. So that's one of our sides.
Congruent to.
Yeah.
And
Okay.
then the
What do you do
two
with
and
the
the
two
one
and
are
the
the
one?
same thing.
You see how this side is the same as itself?
Yeah.
That's a side. And
So that
then
would be line WV is congruent to line W.
that's the reflexive property. Okay?
Oh, shoot.
But if you look right here, this is 2 and this is 1. So 2 + 1 is.
No.
This is 2 and this is 1, so 2 + 1 is
Three.
3. Aren't those the same length?
Yeah.
So then you would have to do like the segment addition postulate, the segment addition postulate, substitution postulate to prove that they're the same. And the transitive property, all this crazy stuff. Look, we're not doing that. If you can understand that this is going to end up being the side shortcut, that's a win in your book. If you could just recognize that side.
Wait, so then can we do the proof for
Can we
this?
do
No,
triangle
no,
side?
I don't want
That's
to.
not going to be on our test.
Absolutely not.
Oh.
Miserably terrible proof. We're
Why
not
don't we
doing
do
that.
side?
Because this side and this side are the same. This side and this side are the same. And this side and this side take some work but can be proven to be the same.
But can we do side and this side?
No. There's no way to do angles. What angle are you talking about?
Angle W. Wait, does it have to be the same and W?
So some people will try and do, oh, Baker. They'll try and do this because they're vertical angles.
No, I'm talking about like
Oh.
angle W.
See that?
That's not even part of the triangle.
It is.
It is.
It's
well,
not.
then you
Well,
have like
it
a
is
whole
not.
other section.
Then they're like, oh, that's ass then, because you get angle side and angle side, but that's ass. Doesn't work.
No, but like angle WVZ.
Angle WV is like this angle
Yeah,
right here.
right there.
You don't know what the size of that angle is. You don't know if it's a right angle or not. All right, let's try this one.
Okay.
I know. We can do it, guys. I know we're speeding through this, but coaching duties call. It is what it is. We're writing this one down. So we need to plan our proof. And I'm going to be a good student and figure out A, B, C, and C, D, A. I'm trying to prove that those two triangles are congruent.
So first you gotta do the given.
No.
I would draw the parallel lines.
Okay.
No.
Well,
No.
no.
Okay, press it.
Okay, so since they're parallel lines, there's alternate interior angles.
Yeah.
You guys need to look at the triangles
Okay.
and plan for what
Ooh,
shortcut
A,
you want to use.
S, AS.
Right now, I have a pair of S's.
SAS.
Okay, hold on. Let me catch up. This S is congruent to this S.
Yes.
Reflexive.
And I have my reflexive S's. And now,
Oh, well, okay.
parallel lines create
An alternate.
angles, right? Alternate interior angles. So if I could say, is there a way to say that these two angles are congruent?
Yes.
Because that's the A between the S's. That's the alternate interior angle theorem. So I'm going to plan on using the SAS shortcut. That's worth points right there, knowing what shortcut to use. Okay, here we go.
Wait, okay, so what if you forgot about the like sides in the middle and then you made the other two angles for vertical angles?
There's no.
I mean for alternate interior angles.
Then that would be the ASS shortcut, and it wouldn't prove congruence.
Or
So-
AAS wouldn't like
Well, no.
if you
If-
made,
I get what she's saying.
like
if
if you
you-
made two more angles on the
Okay,
inside.
if you mistakenly said this one and this
Yeah.
one, that's not going to work because you don't know if these two lines are parallel.
Oh, okay.
You see how that
Yeah.
I kind of guided you to that, which ones were the right ones. Let me find the right color. Baby blue. Okay, so number one. Y'all see that color okay? Side BC is congruent to side DA. Here you go, Mikey.
Oh, no, I didn't do that.
It's my job to make you hate me. Am I good at that?
No.
I love you too. So in this first statement,
But sus.
I have a. I love you too, Vic. We'll be forever on the internet. In the first statement, what did I describe? An S or an A?
People are gonna listen to
An
this
S.
audio and be like, what the heck?
Okay, so I have an S checked. I need an A and another S. Which one's easier for you to do first?
A.
The A?
S.
So just do.
Oh, I found that.
I think the S is more. Most people will see the S before the A.
I did.
I saw two A's before.
Lot
So
side
it's like
CA is
So-
congruent to side CA.
Side AC, CA doesn't matter.
Reflexive property of congruence.
Most people will see that one first. The
And then-
reflexive property. Hold on, let me write it.
Wait, so if you say like angle C, is it the whole angle?
You
Like
can't, and that you can't say angle
I know,
C.
but like just like in general.
And
Half
then you
of
can be
angle
like,
C.
No, and that's and people
Angle C,
people miss points for this part. So remember,
Angle C.
statement number 2 is an S statement. Check. Now I need my A statement. That's all I need. That's all that's left.
angle BCA.
Perfect. So
It's
you have to
congruent.
name it by its angle name. Angle B C A. You have to trace it. B C A. That is the only angle described by
Is
using.
congruent to CAD. To angle CAD.
And the reason that's true
Alternate interior angle.
is alternate interior angles. Look, that checks my last A.
And
So
then-
even though it says ass backwards on the side of my proof, what order are they really in? SAS. So that's enough information to write triangle ABC
Oh shoot.
is congruent to triangle CDA. And the shortcut I use to prove congruence.
SAS.
You know what?
Good. I said, look, and this is hard, right? We thought AIA and AEA and SSI and SSE and OSSI. Some of you guys put that on your quiz was weird.
What? Oh,
Opposite side interior angles, like I get it, like I can figure it out, but then you're done. Look, that's a very typical proof that you guys will do on your test.
Then I did 5 steps because you did the other.
That's
things.
okay. And how, Mikey,
Doesn't
that's a
matter.
great question. How am I going to fix that on your test to make sure that you do 4 when you're supposed to do 4?
Are we supposed to do 4?
How do you know?
Well, you could have
You
done
know.
two given.
Because on your test, there is only,
4 likes.
and you can, that's it. It should fill that. There should be no
Oh.
less, there should be no more.
Yes.
It is that or it's wrong.
Wait.
You're
No.
So we can't put like
There's
the
no
given
way.
on-
And I will tell you on your test, statement 1, there's one given statement in this proof. Number 2, there are 2 given statements in this proof that will force it to fit.
Oh, okay.
Okay? All right. What else is on there? How else can I torture you?
Example.
Roll.
Yeah, I need practice.
Okay, we're going. Here we go. Next one.
Well, no,
This
my-
is an instance where they don't provide any information in this proof for you.
What's
Oh,
this?
first we have to figure out what we want to prove.
What's this upside down?
Okay, listen.
That's
To figure out what angles
Okay.
he's talking or triangles.
Now look, we need to fill in what they gave us because nothing's listed in the diagram. Then we need to plan what our proof is going to be. WY
We can do.
and XZ, WY, oh, can I mark it like this? Is that going to bother anybody?
No.
WY and XZ are the same?
Yeah. I'm trying to find out which triangle we're talking about.
Can you like
Wait.
spread it out? Wait, it's
yeah.
not lights. Oh, I get it.
Jayla, that is a great suggestion.
Great.
It's awesome.
Do we have to try?
No. So right now I know this is true. That's a little clearer to see though, isn't it?
Yes.
Okay. And I know that WZ is perpendicular to ZY. How am I supposed to mark that?
Like a
90
T
degree.
or something.
90 degree.
Oh.
And I know that XY is perpendicular to ZY.
The T.
Okay, so I'm planning my proof. Now here's where separating them may be a little bit more complicated.
You can't use your.
Oh, we can do the.
Okay, no, I can, but it's harder to see because this is ZY and this is ZY. But it's easier to see in the actual proof. Does that make sense?
I think.
So that would be.
Okay, so
I think it would be reflexive if you did it.
it is the reflexive property. So look, I just added the information that I know. Now I'm trying to settle on
Wait.
I'm trying to settle on an actual shortcut because it is true. It can be done, but I'm trying to figure out how can I do it.
How did you just do that?
Oh, I was like, that's ASS.
What did you? Why?
Yeah, it looks like ASS, doesn't it?
How's it with the 3?
HL.
Because right here the reflexive part.
Oh.
So it looks like
Or we
ASS,
do it H.
but it's HL.
Oh.
So the shortcut I want to use is HL. And what does HL only work with?
Right angles.
Right angle.
Right triangles. That is uber important. Mikey, how do you want to do it? 3 statements or 1? One? Okay, number 1. WY is congruent to XZ and
So we're writing all of
WZ
it?
is perpendicular
Oh.
to ZY and
Nah, I'm just getting 3.
XY is perpendicular to ZY.
This is not gonna fit, Mikey. Mikey, why did you choose this?
Just draw a big T.
I'm starting over.
Okay. They gave us one thing. This is the only thing they gave us right here. What did they give us?
They gave us a side.
Side doesn't exist in HL.
They gave us a hypotenuse.
They gave us to the H. So right now, this is my H statement. Check.
H. Check.
I need to do the L.
Delay. Oh, the reflexive.
The
property.
reflexive part.
Delay.
So ZY is congruent to itself. That is the reflexive side.
Oh, I'm a little behind.
Then triangle. WYC.
No.
But that's HL.
Yeah.
Triangular.
Does it say, listen, this is the one that everybody misses on their test. Does it say anywhere in our proof that these are right triangles?
No.
Yeah.
Because this only works for right triangles, doesn't it?
Angle.
Does it say that they're right triangles?
No.
So I
We gotta
have to
add an
put
angle.
that in my proof.
Angle Z is congruent to angle.
Supplementary.
No.
You gotta put
Angle
angle
Z is
WZY.
No, listen. I have to put a statement that says they're right triangles.
But didn't they
Triangle, where?
at WZ is perpendicular to ZY? Where then why'd you put it?
Because the perpendicular part is given. So I can't say that triangle WYZ and triangle XZY are right triangles. I have
You
to
just
put
write
that in
that?
yeah.
Oh.
I have to put that because if they're not right triangles, HL doesn't work. And then here the hard part is like, why the hell are they right triangles?
Because they have a 90 degree.
Because they're perpendicular. So that is the definition of
Okay, now we're just making
perpendicular. Right? If they're perpendicular, does that create right angles?
Yes.
Yes. If there's right angles, does it make them right triangles?
Mhm.
Yes. So now I have my H, my L, and I have they are right
Okay,
triangles.
wait, so for step 3, could you also put like angle WZY is 90 degrees?
Yes.
And then you do the same. Or you put angle WZY and angle XYZ are 90 degrees. And then
Yes.
you put definition of perpendicular.
Correct.
Okay.
So
Which one's the L?
The second.
this one's
statement.
the H, and this one's the L.
Oh.
The L
So
statement's
two is
right
L.
here. Sorry. And this is my right triangle statement. So now I have enough, number 4, to say triangle WYZ is congruent to triangle XZY
HL.
HL. Did you die?
What?
Okay, let's grab the other set of notes and keep going. Guys, we have to have the practice. Look, you're doing this once a day. I'm doing this 4 times a day. We can do it together.
Wait.
You're looking for the one that looks like this.
Where?
Oh, I see it. This one. No, I
Oh.
There it is. Okay. Look, we need to go back and fix a few things. On number 8, there should be a little congruent symbol right here. On number 9, there should be a little congruent symbol right here. That's going to allow us to
That's a lot of steps.
skip step 7. It's a lot of steps, but there's one part in this proof that is uber important that we need to learn together.
Can we do angle side?
Let's look at it. So we're thinking angle side. I see this angle is congruent to this angle. And I see this side is congruent to this side. What's the other?
Angle.
Right?
Double.
HL.
Okay, this angle is congruent to,
X, but like.
yeah, so we're going to say that these 2 angles are congruent.
Yeah.
That is the angle side shortcut. That is exactly right. So we have to find some way to justify that angle X is a right angle in our proof somewhere.
Would it be the HL?
No. So I can't use HL because I have a pair of H's, but there's nothing that says the L's are the same. There's no other way to say the sides are the same.
Can the L be, does the L have to be on the bottom or can it also be on the side?
It's indiscriminate.
Oh, okay.
It could be the top or the bottom. Okay? So angle UWV is a right angle. That is written right here. And we're trying to use AAS.
So that's A.
That's not an A.
No.
That's just, it's a right angle.
Oh. Well.
So I'm going to write the next given parts. TX is parallel to VW.
Oh.
TU is congruent to VU. Now that part TU is congruent to VU, that's my side statement. Check. Remember, this will forever be on the internet. So will you saying, slow down. Link cross.
Loser. And you.
Saying that you love Luke.
Okay.
And
I love you too, Jim.
You know, love's a strong word.
Yeah,
I don't really
like,
think I can describe
you can't
it.
just spit it.
Let's keep going. Then we have angle XTU is congruent to angle WVU. I'm just copying things out of the proof.
It's a princess handwriting for the video.
Man, this is nice handwriting.
That's an A statement. So I have
As.
one A and one S. I need one more A statement. So right here, this is what Luke brought out. Angle UXT, this angle right here, is a right angle. It's not given.
Definition of
It says it up there.
The
perpendicular.
definition of perpendicular. No.
Oh, I see.
Erase that. It's not right. Does it say anywhere that TX is perpendicular to XW?
No.
Definition.
Hey,
of
hey,
writing.
listen, stop talking, listen. Remember that conversation we had about railroad ties and rails and railroad, remember all that?
I mean, parallel. No.
If
No.
these two lines are parallel, and this line is perpendicular to this one, it is also perpendicular. Remember that, like draw apple
Oh,
street?
yeah.
Oh.
Remember all that?
Same side interior.
The perpendicular,
No, that's right though. That's actually right though.
the perpendicular transversal here. Same side interior angle says that those two angles add up to 180. It doesn't say that the other angle is 90.
Perpendicular.
So
But it
this,
does. It does.
you have to do more math. This specific theorem says that angle X is a right angle. Period. You're done. Period. T.
Theorem.
Now,
When did we learn about that?
this is the part that people miss on their test. Does it say anywhere in the proof that this right angle is congruent to this right angle?
Right
Yes.
there.
No.
It does.
Okay, why are these two right angles congruent then?
Given.
It's not given anywhere.
Definition of perpendicular.
No.
Oh, I was
Wait.
You don't
A is given.
WV.
A is given.
All right angles are congruent.
Oh.
Oh, because there's this neck.
Duh, right? Why does 90 equal 90? Because 90 always equals 90.
Number 8 is given.
And then number 8,
Is it?
It's given because it's in the given.
Wait, okay.
It is in
For number 5,
It is.
I guess I repeated myself.
Yeah.
Uh-huh.
No, wait, now you're just like us thinking this.
A's.
So this is repeated.
As.
These two steps are repeated because this was an equality statement, so it doesn't necessarily need to be there. But look, at the end of the day, we use the AAS shortcut.
So number 8 is given. A S.
Oh, you know why? Hey, you know why we screwed it up?
why couldn't I do same side interior?
Okay, because the same side interior angle theorem states that those two angles add up to 180.
Therefore, I can conclude that the
No,
other
they
one's
could be
90.
like, they're not.
No, so then you would need another step to say that this angle plus this angle equals 180. You'd use the subtraction property to say that this angle equals
Oh,
90.
that's too
It's
much.
3 more steps.
Oh.
This one goes right to it.
Oh.
All right, last one, and we'll quit.
No,
Last one.
Yay.
I like this.
It can be fun. It can also be very stressful. But look, this is one of the reasons that my
A
students do
paragraph
super
worth?
well, because I just force you to do proof after proof after proof after proof.
Because-
Okay, plan our proof. Plan it. Plan it. Plan it.
So there's a reflexive side. so
Attaboy.
that's one.
This side is the
SSS.
reflexive side.
Yes, yes,
Yes,
yes. Yes, 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 yes.
SSS.
I rescind my attaboy. Bad.
What?
Okay, there's.
No, it's S.
No, it
Because
says
there was no
SS.
parallel line.
Okay.
What I was saying earlier, the two
Okay.
alternate
Mikey,
interior
Mikey,
angles.
is there any way to justify that these two sides are the same size?
Yeah.
No.
I mean, A.
What do parallel
What?
lines give us?
Angles.
So listen, this is important.
So that's
This
not
side
reflexive.
is parallel to this side. That gives me
The angle.
alternate interior angles. Hold on, Baker.
You did it wrong.
Alternate interior angles.
If-
And this line is parallel to this line, which gives me alternate
Another
interior angles.
Yes.
So as you plan your proof, we need to do the ASA shortcut.
Asa.
Okay?
As a,
Now when we write that down, write our givens.
Wait, we did it. Oh, it's kidding. No, it's just because you did it
Why,
a
if
different
you don't-
color. And I didn't do it in a different color, that's why.
I don't know why this is here.
You're on the record.
no one knows.
It's
Wait, it's
What are you doing? Are they pair?
Okay? So our plan of attack, we need to
Why are they
describe the reflexive S. We need to describe the blue angles. We need to describe the maroon angles or the red angles. Angles or sides first?
Side.
Side.
Angle. Side.
Okay?
yeah, side.
Side WZ. Was it Z?
WY.
It's-
Side WY.
Where'd you get Z from?
He's done this 4 times a day.
Side WY
Is congruent.
is congruent to side WY.
Reflexive POC.
Some kid's gonna listen to this and be like, what conversations?
Oh, wait.
Probably think your class is annoying.
Okay?
Probably gonna think
This
we're
is
not.
our side statement. Check.
Check.
We need an angle statement. Now, the hard part about this is naming the angles correctly.
Angle ZWY.
Okay, hold, slow down, let me find it. Angle ZWY is one of the red angles.
Yes.
Is congruent to angle,
What did I just say?
X. No.
yes,
XYZ.
XYW.
Writing 7.
Z.
XYW, and that's a very common mistake. Those two angles are proven to be congruent because of the,
Alternate into AIA.
it's an angle statement.
So now we gotta do the same thing.
You could do XY. Wait, hold on.
XWY
XWY is congruent to WYZ.
is congruent to WYZ.
Yes, you can. You don't have it.
Angle.
Oh, yeah, you're right. No, you can. Can you do the
That's
third
another
angle?
angle statement.
Oh, yeah.
That checks off the 2 missing A's that I have. I'm going to use the angle side angle shortcut, number 6, to prove that triangle, just copy it down, WXY, is congruent to triangle YZW. And the shortcut I'm using to justify that is angle side angle.
Yay.